this is like, we're still continuing on in this stupid chapter 6.
Yeah, we talked about the
It's like sig figs and dimensional analysis. Willie, all your words are being notated here online. Okay, so call this what, Charlie? 6B, I guess?
6B.
Or, yeah, 5B.
5B.
Call it 5B. And guys, one more time, what's the stupid sig fig stuff supposed to convey?
The accuracy.
Accuracy or degree of certainty, right? And all measurements, true or false, are all measurements estimate the last figure. True or false?
The last significant figure?
Yeah. True. All measurements estimate what? The last figure in the sig fig thing. Okay. So this page right here is just a quick review of sig figs. Let's look at it. Going around the room, Betsy, how many sig figs in the first one?
2.
It's a real toughie. Next one, Scott. 2. Next one, Willie.
3.
Right. Next one, Pat. Pete. 1.
Wait. Are we looking at the examples or the one?
Yeah, we're not looking at the
Number
examples.
4?
Number 4.
1.
1. Good. And by the way, I have this little packet here that we're going over. All right. 4 for number 5. And number 6? Who's up? Courtney.
2.
2. Good. Stephanie, number 7 is a toughie.
2.
Good. Next one, number 8.
Me?
3.
1.
Which one, Steph?
1.
1. Leading zeros?
Don't ever count.
Never count. Leading zeros never count. Then the last one, so Dylan, number 9, not the last one. Number 9?
2.
2. And cover.
2.
2. Good. Now, watch what's going to happen on the hard things like this. What if she says she wants to go from some centimeters? I'll do that later. Next page. Did we do adding and subtracting last week? No, I don't think so.
Oh, no. We didn't start that until like after we started.
All right, so here we go. We're going to do these. There's 2 different rules. One for multiplication and division, one for addition and subtraction. So the rule for multiplication is find the sig figs, multiply them, and get your answer rounded to the least number of sig figs. So if we got 12.6 times 2.0 times 13.84, how many sig figs in the first one?
3.
And then 2. Leading zeros never count. Trailing zeros, yes, with a des. And 4, yes? So if somebody calc it, punch, button punch, and how many sig figs is our answer going to be? Guys, whip out your calculators.
Oh, I got 2.
Everybody, don't leave it all on Betsy.
I just turned my phone off.
So give me the whole answer, and then we'll work it down.
13.8.
Yeah, 13.84. That looks like a retarded 4.
348.
Say it again.
348.768.
Okay. Now, how many sig figs do I want in our answer?
2.
2. Why? Because there's sig figs up here. We have to go to the least. So we want 2. So do this, guys. Underline the first 2. That's how many we want. And then round until you get to the 2. So what's that final answer going to be?
350.
350. Yeah, and that's 2 sig figs. And then if we had to go scientific notation on it, you probably don't because it's just hundreds. Most teachers will let you slide without doing scientific notation on 350. But if we did have to do scientific notation, what will we end up getting?
2.5 times 10 to the second.
3.5 times 10 to the second. What about that 0? Shouldn't I bring it over here?
No, sir.
No, because it's not part of your sig figs. If there are 2 sig figs in your original answer, there can only be 2 sig figs in your scientific notation. Everybody clear on that one?
Yeah.
Okay. Then,
But don't you also have to like square or like cube like the number of like meter measurements? So like if there's 3, that's going to be meters cubed or whatever.
yeah, I'm going to do that a little later.
Oh, okay.
I was waiting on that, but yeah, that's an important point. Okay. Now the next one. Well, we're going to skip and do number 27. So 1.360 times 10 to the 5. What bearing does 10 to the 5 have on your sig figs? None. And then 6.05 times 10 to the negative 2. Okay. And they're both centimeters. So Willie is going to say, well, if they're both centimeters, our units have to be what?
Cubed or whatever, or like multiplied.
Yeah, so squared.
Yeah.
So your answer is going to be semi-squared. But even before, how many sig figs over here? Everybody look. 4. And over here? So our answer should have 3.
Because you use the last one. The least. The
least. Not the last, the least. Okay, somebody calc this yet?
Unless you do 10 to the 5th.
Well, no, just just
just
multiply those two and then just add those two. You guys see how to do this? Just multiply and then add.
Alright, 8.228 is
8.228 times 10 to the 3. What? Semi? Squared. Don't forget to square the semis because you're multiplying them, right? Okay. Now, how many sig figs do we really want? 3. So we got to round this guy and make it 8.23 times 10 to the 3.
Does the 5 and the negative 2 exponents, do they like offset each? Oh,
They
they
add.
go to cube, yeah.
5 minus 2 is 3.
Yeah.
You just add the exponents.
Right.
But how come you get the centimeters cubed instead of centimeters squared?
It's squared. Oh, did I? Good. I don't know what happened.
Oh. Okay.
So centimeters squared up here, and it should be centimeters squared down there. Good call.
And then up above, would you say, like, would it be meters cubed, or would it just say it's meters?
Where?
Like,
Here?
in the first example
Meters
on the...
cubed.
Oh, I didn't do the ones in the first one. I see. Yeah, it's meters cubed says Willie. Meters cubed in the first one.
When they're using them, like, when you're multiplying them, they
Yeah.
add the exponents.
When you're multiplying, this is algebra. So, you remember algebra?
Wait, but why is the centimeters squared?
There's 2
Because there's 2 centimeters times centimeters.
Oh, you multiply the units?
Yeah. So that was Stephanie's point and Willie's too up here. Look up here, Dylan. Meters times meters times meters is meters cubed. There you go. Okay. Willie, leave him alone. Okay. Now, look at number 30. You guys still with me, number 30?
Yeah.
18.5. Division is the same thing as multiplication in terms of operations of sig figs. 0.035. What are the units here? M and S. Okay. So, how many sig figs in the top?
3.
And how about the bottom?
3.
Ooh,
I
Peter.
said 2. I don't know.
Leading zeros
No,
never count. So 2 in the bottom, 3 in the top, so we want 2 in our final answer. And our final answer is just going to be M over S, meters per second. So what do we get?
528.571429.
528.5 what?
0.571429.
Okay. So, and that's what, meters per second?
Yeah.
Okay. Now how many sig figs do we want?
2.
2. So put a bar under the first 2, so that you know that's how many you want, and then round up to the bar.
530.
So 530 meters per second. And if we did, this is interesting. If we did scientific notation, it'd be 5.3 times 10 to the 2 meters per second. Betsy, okay?
Yeah.
Anybody have any questions? Okay, now, totally different analysis. You guys ready for this? Totally different analysis. Addition and subtraction. Totally different. For addition and subtraction, look at number 26. We got 13 centimeters. We got 10.4 centimeters. And we got 1.25 centimeters. Now what are we doing? We're adding, yes?
Yeah.
Now, when you add scientific figures, you don't care about total digits. You don't care about the total digits. All you care about is dear old dad. Dear old dad. Digits after the
Like,
death.
should that be a DOD?
After?
Oh.
He's the same as the That's what I thought too, don't worry. I was like, why don't we just call it dad?
Oh,
But
dear old dad, no, it's dear old
It should be like
dad.
God.
The dear old was just a prelude.
Okay.
The dad, digits after the death, but thanks for doing the linguistic analysis for me. Okay, so now, how many digits are the death on this one?
How many?
2 digits after the decimal.
Oh, yeah.
2. How many digits after the decimal?
Yeah.
How many digits after the decimal? So you take the least number of digits after the decimal, not the total, just the digits after the decimal. I don't care about the total anymore, just the digits after the decimal. So we're going to work it out. 5, 6, 4, 2.
23.65.
That's out 4.
Yeah.
You're wrong.
Oh, my bad.
Okay, so 24. And how many digits after the decimal do we want? None. Look, 2, 1, none.
It's amazing.
There's no digits after the decimal, so our answer is 25. And then this time the centimeters don't multiply. They just stay the same. 25 centimeters. Yeah, is everybody cool with that? So you don't look for the totals. You don't care about the totals. Just digits after the decimal. Yeah. In other words, this could have been like, while you were to look, this could have been 415, 673. I don't care. It still would have just gone down here, and the digits after the decimal is all I really care about. Everybody good? Okay, next one. Number 28. You guys do this on your own. 11.63 minus 8.8, and they're both milliliters. Is this subtraction? Yes, it's a minus. Is that right?
Yeah.
No. What's the right answer?
2.8.
2.8. Only one digit after the decimal. Therefore, only one digit after the decimal. 2.8. Scott, that make sense? Good. John, you all right?
Yeah.
Okay, 28. No. Not 28, 29. 29 is a hybrid. You got a subtraction on the top, and you got a division on the bottom. What should you do first?
Subtraction.
Subtraction. So subtract those two guys. 1236 minus 1125. And they're both G's. So we get a 1, 1, 1. And is that right? Should I have 2 digits after the decimal?
Yep.
Yeah, that was easy. And then, now we shift gears. First and the second. Now we do division.
Oh, wait.
So we take the 1.11 grams and we divide it by 10.31 milliliters. And now, true or false, I care about digits after the decimal. False. Now I just care about the least total. And the least total would be?
111.
What?
3. Trevor, 1, 2, 3. You gotta look at the top and the bottom. You know. You check somebody out, you don't just look at the bottom.